So a question came up recently about testing a capacitor under load. That's the way that we test a capacitor, by not unwiring it from the system, but yet leaving it in place, running the system, and then checking voltage across common and Herm, and checking your amperage on the Herm wire, and then plugging into a formula to determine what the capacitance is with load on the system. And the question was, if the system is being tested with low load conditions, like typical spring PMs when you would be testing a capacitor, could that reading be off because of the low load, and could you be replacing capacitors that aren't really bad? So here's what we're going to do. It is in the mid-60s here. It's a cool morning in North Carolina in the beginning of August. We're going to wet this condenser coil down, so we're going to simulate a low load, and we're going to use a capacitor under test method, and then we're going to run this head pressure up by covering up the condenser coil and running the head pressure up significantly to simulate a high load. We're going to use that method again and see whether our capacitance actually changes, and then we'll talk about our results after the test. So here we go. All right, so we are wetting the coil down so that we're going to simulate an even lower load than what we already have here, with the weather being in the mid to high 60s. That way we're going to run a really low head pressure. We test this capacitor. Okay, so as you can see, our head pressure is pretty low for 410. We're running about an 85-degree condensing temperature, just about 280 psi. So we've got a lower load situation here. Now we have got to take two electrical readings in order to plug this into our formula. The first is going to be a voltage across our start winding, which is COM to Herm on this run capacitor. And we're reading 371 volts. So we're going to remember that, 371. Then we're going to take an amperage reading on the start winding, which is this Herm wire, this yellow wire. And that's 6.5 amps. So we're going to remember those two readings. We're going to plug it into the HVAC School app tool for measuring or calculating capacitance under load, and we'll see what we get. All right, so let's see if the capacitance value changes when we increase the load on the system. So as you can see now, our head pressure is close to 400. So we've raised our head pressure 100 psi by covering up this coil. We're going to take these two electrical readings again, plug them into the HVAC School app, and see if our capacitance value changed. So first thing we're going to do is check voltage on our start winding by reading common and Herm. As you can see, that's 361 volts. So we're going to remember that, 361. We're going to switch our meter to amps. Now we're going to read our amperage on our start winding, which is our Herm wire. And we're going to read 6.3 amps. So we're going to remember those two readings. We're going to plug it back into the app and see if our capacitance changed. Alright, so let's talk about what we found. Our original voltage was 371. Our new voltage was 361. Why did that go down? The reason is because when we put the system under load, we're putting a strain on this electromagnet. We're fighting the electromagnetic field, and we're going to see that load with a lower back voltage, which is what we read when we read that 371. It's a back voltage that the electromagnet is producing. When we see a lower reading, that means that electromagnet is under load. So it's very normal to see a lower voltage across that start winding when we put a load on the system. The second thing that we read was a lower amperage on our start winding, or our Herm wire, when we increase the load. Now that may seem counterintuitive. Why would our amps go down if our load goes up? We've always talked about when load goes up, amps come up also, but in this case our amps went down. And the reason is because our start winding is not looking at the load that's being put on the motor. Our start winding reading is looking at the effect that the capacitor has on the start winding. The run winding is the winding that sees the load on the motor. And in this calculation, we're not looking at the run winding, we're looking at the start winding. The best way to read the actual load on the motor is to check the amps that is on the common wire of the motor, because that common wire is going to read a sum of the start and the run windings. So in this case, the common wire is this black wire. And notice how our amps are a lot higher. It's 9.2, 9.3 amps. This is the actual amperage that the motor is seeing due to the load. Now what happens when we all of a sudden take away the head pressure on this system? Notice what happens. Exactly what we expected to happen. The amps drop from 9 point something down to 7 point something and even lower. And that's because when we read a sum of the run and the start windings, we're reading the actual load on the motor. If we're checking amperage on the start winding, we're not actually seeing the load on the motor. All right, so let's summarize what we found. In either case, with a low load or a high load on the system, when we plug those two readings, the voltage and the amperage, into the formula, the capacitance was exactly the same within 1 microfarad. It read 46 in both cases on a 45 microfarad run cap. So why did the load not have an effect on the capacitance? Well, because when we're reading on the start winding, which is the reading that we take on this capacitor under load test, the start winding doesn't see the load, doesn't care. So the premise that when amps go up with the load going up, having an effect on our capacitance formula is flawed, because the capacitance formula is not even looking at the load on the motor. It's simply reading what the effect the capacitor has on the start winding. So in this case, reading capacitance under load is still a good test. To me, it's a better test than a bench test. And as I've posted before, if you get a meter like this one, you can also read power factor, which is also a great way of testing capacitors under load. But don't be afraid to test a capacitor under low load, under a high load situation. That formula will work in both cases. If you have any discrepancies in your readings, you probably have something going on with your meter, and maybe get a second meter and take a second reading on that and compare the two, because sometimes our meters under certain conditions don't read amperages correctly. Sometimes we don't get exactly on the center of the amp clamp, and that's going to throw stuff off. So take readings as accurate as you can. Make sure you can trust your instrumentation, and don't be afraid to check a capacitor under load. This is Tim DeStasio. Thanks for watching. Leave some comments below. Be safe.